hopefully you notice that this root is repeated. It has two factors that give that root. And so why is it that if it's repeated, it is going to bounce off the x-axis? Well, to see this, let's think first about a root that isn't repeated. So let's consider the root at -1. That's the root we're going to think about here. So think about what happens when you plug in, the root at +1. So think about what happens when you plug in +1. Well, when you plug in +1, you're going to get 0 here. So that's going to make the whole function go to 0. But what happened before we were at 1? Imagine what happens when we were at 0, when x was 0. Remember, when we plugged in 0, we got 2 times 2 times -1 times -2, which is a positive number, right? And we got that because the sign of each factor. When I was at 0, the sign here was positive, the sign here was positive, the sign here was negative, and the sign here was negative. What's going to happen when I pass through 1? What's going to happen to the signs of each factor when I'm at a value just a little above 1? Well, nothing's going to happen to this factor. It's still going to be positive. Same here. We'll skip over this one. X minus 2, right? If I just go to a little bit past 1, it's going to stay negative because 1.1 minus 2 is still negative. But this factor is going to change sign, right? Because it equals 0 at 1. Before 0 it was positive, and after 0 it's going to be, before 0 it was negative, and after 1 it's going to be positive. Let me say that one more time. If I plug in, I'm thinking about this factor here. If I plug in a value less than 1, it's going to be negative. If I plug in a value greater than 1, it's going to be positive, right? Because I'm subtracting 1. And so the sign here is going to change. Well, if I change the sign of this one factor, remember all the other signs stayed the same. So instead of having a positive number, doing positive times positive, this was negative, but now it's positive, so it'll be a positive times a negative, which will be a negative value. Since this factor changes signs, the whole function is going to have to change signs. I'll let you pause for a second, think about that. Hopefully it makes sense. If not, rewind, go over it again, make sure you understand that if I change the sign of one factor, the sign of the function also is going to have to change, right? Imagine if you have an odd number of negatives being multiplied versus an even number of negatives. When you change it, the sign changes. So when this changes from negative to positive, so will the sign of the overall function. But what then is happening at -2? Well, to see that, let's consider. So when we're at -2, obviously this factor is going to be 0, and so that's going to cause us to have a root. The whole function will be 0. Well, for every value less than -2, let's say -3, let's just use that as an example, this factor will be negative because a -3 times a -1 is negative. And for all values less than -2, this will also be negative. What about this factor? Well, remember what happens when you square any number. It's of course going to be positive. So even if I plug in a number less than -2, this will be positive. Oops. This will be positive. So I'm going to have a positive times a negative, which will give me, of course, a positive. And so no matter what I plug in to this factor, it's always going to be positive. And so that means that when I hit the root at -2, nothing changes about this factor. It's still going to be positive because I'm squaring that number. And so while these roots will be negative for all those values, right, x minus 1 will always be negative when x is less than 1, and x minus 2 will always be negative when x is less than 2. These aren't going to change yet. I'm going to always have a positive times a negative up until I hit at positive 1. So it's going to be positive all the way until I hit at 1. And so notice that since I have a factor which never changes sign, can the value of the function change at that point? The answer, of course, is no, because since this isn't changing sign, nothing about the function is changing at this point. And so when I have any factor whose sign is not going to change, I'm not going to change the sign of the function either. So now think about, will this only work if I have a factor which is squared? The answer is no. It'll happen for any even numbered power, because any even numbered power is always going to return a positive value. It's never going to change sign. So if this were x plus 2 to the 6th power, it would never change sign, because anything to the 6th power is going to be positive, and so we would see it not change sign and bounce off just like we did here. Okay? So we want to put this into a really concise way of understanding what's happening. When I have a root which is what we call repeated, so this root happens twice, right? It's repeated in the function. If it's repeated or has what we call multiplicity of an even number, or it's repeated an even number of times, then the function isn't going to change sign. It's going to bounce off in whichever direction it came from. Right? So if it were coming from the negative side and it had an even multiplicity or was repeated an even number of times, it would bounce back, because the sign isn't going to change. All right? And if we have an odd multiplicity, right, a factor which is repeated an odd number of times, imagine it were to the 3rd power, right? Anything to the 3rd power will change sign depending on whether the value is positive or negative. So if it has an odd number it's repeated an odd number of times, it will have to pass through, because that factor is going to change sign at that root, right? It's going to be going from either positive to negative or negative to positive. So written down, right? The multiplicity of a root is the number of factors which give that root. So for example, if I had x plus 2 to the 3rd power, then it has a multiplicity of 3. It's repeated 3 times. And so given any polynomial function, a root with odd multiplicity, well, what will happen at that root? Well, it will pass through the x-axis. And if it has an even multiplicity, it will bounce off the x-axis. This is what we look at. This is what we see happening. Another word for pass through would be to say that it changes sign. Right? In order for it to pass through, the sign must change. And if it has an even multiplicity, well, it bounces off, meaning the sign stays the same or does not change. Stays the same. Okay. So let's look at one more example here. We want to write a polynomial function that could be represented by the graph below. Okay. So if I look at this graph below here, first off, I want to be able to write the function, so I need to know what degree polynomial it's going to be. Right? Well, notice that we have 1, 2, 3 roots, so I might be thinking this is a cubic. If you think that, right, I want you to stop right now and consider, could this be a cubic function? Hopefully you realize it can't, because a cubic function can't have the same end behavior, and this does. So it can't be cubic. It could potentially be a quartic function, because it has the same end behavior. And if it has a quartic function, right, and it has 3 different places where it hits the x-axis, well, what does that mean? Remember, if it's a quartic function, it must have 4 roots. And if it has 4 roots, it's got to have 4 factors. All right? But notice that each of these factors, or each of these roots, is going to give me a factor that repeats an odd number of times. Yet this factor will repeat an even number of times. So if we want this to be quartic, we need 4 roots. 4 roots. Let's deal with the first root. If we have a root at -1, well, the factor that must come from must be x plus 1. And if it bounces off the x-axis, it's got to be repeated. It doesn't change sign. It's got to be repeated at least twice, because it has to be an even number of times. And so we have another x plus 1. Stop for a second and consider, why couldn't we just do it 4 times? Well, then we'd have all of our factors filled up, but we'd still have 2 roots to take care of. The next root happens at 0, so that's a factor of x. And the next root happens at +1, so that's x minus 1. And there we have our function. We can simplify because these 2 factors are the same, so it's x plus 1 squared times x minus 1. And this function could be the function which gives us the graph